All right, here's the homework problem from 10.2.3. This was like conditional probability and the idea of association and independence. The first part is just conditional probability. And so it's asking, what is the probability of traveling with a laptop if you know that somebody is traveling for business? So let's look at how many people are traveling for business. There is 236 plus the 274. So when we do that quick, 236 plus 274. So there is 510 people traveling for business. We know that 236 of those people, 236 out of the 510 have a laptop while they travel for business. And so that's going to be the setup for this probability. And so we have 236 that have a laptop out of the total 510 people. If I do that division here, 236 divided by 510 gives me 0.46 approximately, which is about 46%. So there is a 46% chance that if you know somebody is traveling for business, there's a 46% chance that that person is traveling with a laptop. Okay, the second part here is the idea of independence and association. Remember, if two things are not independent, that means they're associated. And for two things to be independent, their probability and their conditional probability need to be the same. So the two probabilities we're going to look at here is the probability, probability, I should just use P, sorry, I'm going to erase that. The probability that somebody owns a laptop, and then we're going to compare that to, or we're going to say, is that equal to the probability of laptop given traveling. We're going to say that laptop given for traveling for business. All right, if these two probabilities that we find out here, if they're equal, that means they're independent, which means they are not associated. If these two are not equal, that means they're not independent, and that means they are associated. So the probability of a laptop, we have 236 plus 93. So 329 people have laptops. So 329 people have laptops out of a total of, let's see, I got to add up everybody now. I got to add up everybody so I can get my total people. 236 plus 93 plus 274 plus 397. So out of 1,000 people, so 329 out of 1,000 people have a laptop. So that's going to be our probability for laptop. And then our probability, hold on right here. So the probability of laptop given that they're traveling, we already did that up here. That's the same probability. And so that's 236 out of 510. And you can see the difference here. So the first probability on the left is your classic probability, the number of people that own a laptop over the total number of people. The thing on the right here, that's a little bit different. That's a conditional probability because we're given this idea that they're traveling, that we know they're traveling. So it cuts down our sample space. You can see our sample space for this one is 1,000, and our sample space for this one's only 510. And the reason that it switched down to 510 was because we were given the information about them traveling. All right. That also switched because we know that they have a laptop and that they're traveling for business, so we only use the 236. We don't use the 329 because we're not including the people not traveling. I just wanted to clear that up because I know that idea can be confusing. So let's talk about the probabilities of the two, and we'll see if they're the same. So 329, sorry for a terrible equal sign here, that's what that's supposed to be. So 329 divided by 1,000 gives you about 32.9% for this one, and 236 divided by 510 gives you about 46% here. And since these two here are not these two probabilities here are not equal to one another. They are not equal to one another. That means they are associated. They are associated. Because if they were equal, they'd be independent. All right, and I think that's all that question asked. Does it appear there's an association between bringing a laptop on a trip that involves flying and bringing a laptop on a trip for business? And the answer is they are associated.